Welcome to lesson 11 on Java int data types. In this lesson we look at the bit structure of the int. We also look at the different formats an integer literal can be expressed in, namely the decimal, binary, octal and hexadecimal formats. We'll also do the following. We'll declare a variable of type int. We'll initialize that variable with a value. We'll use binary, octal and hexadecimal literal in an int. Assign a byte and a short to an int. We'll also look at the overflow and a quick glimpse at the long data type. And lastly, we'll show a mixed example of a byte short and an int. Let's look at the int data type. If you recall, I've shown this sketch before of the Java's 8 primitive types, and we're looking at the numeric integer, the integral part. Okay, the whole numbers in other words. Now we've looked at the byte, which is 8-bit, and we've looked at the short, which is a 16-bit, which stores the number in 16 bits, and now we're going to look at the int. You can see it's a 32-bit. Okay, so let's just go through some theory about it. The int data type takes 32 bits in memory. Okay, so its valid integer literal range is between negative 2,147,483,648 to positive 2,147,483,647, or negative 2 to the power of 31 to 2 to the power of 31 minus 1. As the byte and the short before it represents whole numbers like I mentioned before. These integer literals can be represented in various forms with the integer int primitive type in the decimal number format, which we use at the 1 to 10 and 20 and 30 and so on, the binary number format, the octal number format and the hexadecimal number format. Both the byte and short can be assigned to an int without casting, because the int is 32 bits, which is much larger than the byte or the short. Like all Java primitives, the int has a wrapper class, namely the integer class, and this is found in the java.lang packages, and like the others, there are methods we can use, methods and constances that we can use in the integer class to interface with the int primitive type. You use the int value if the values you need to store information on fits between the negative 2,147,483,648 and the positive 2,147,483,647. It's a long number, but luckily we don't have to remember this. As you'll see, there is a integer max value and integer min value in the wrapper class. Okay, I've got a public class with its main static main method, and I'm going to put the following code in there. And let's see, we're going to start working with the int. And now I've declared I as an int, so variable I, and comma min as of type int, and I can declare two reference variables of type int in one statement. You just separate it with a comma. Then I declare, I say that the I value, the I reference value, has got a value of 25, so I'm giving it the integer literal value of 25, which we know is well within the range, and the min value I'm assigning the negative 2,147,483,648 as a int literal to my int with the name min, then yeah, I'm using the wrapper class max value and I'm allocating it to an int with a variable name of max, and then I'm also assigning 0 and I'm giving that one the name of decimal underscore 0. Okay, then I'm printing out, I'm saying I, which is that value, equals to I, min is equal to min, max is equal to plus the max value, and 0 equals to plus the thing. So let's save it, and I'm going to run it, java main.java, and as you see there is my value. I is 25, the min value, there is my min value. It accepted it because it's in the range. It's actually the least value, could say that the int can hold, and there's my max value, the maximum value that can hold, which I got from this wrapper classes constant max underscore value, and there's 0. So that's working fine. Okay, now that we saw how to use decimal literals on an int value, let's look at the binary. I'm going to just add this code here. So here we're using the binary literal. Okay, so in the first line here, and what you must note here, all binary literals start with a 0 small letter b or a 0 capital B. That means that you'll be allocating the binary value to an int. Okay, so in the first one here, I'm declaring, in other words, two int types, one named num1 and num2, but num2 I'm assigning the binary value, and if you know, this is 0 2 4 8, so that would be 8. If you look at my previous tutorials, there's an interesting one about how to count to 31 in your fingers. On one hand, you'll know where this comes from. It's the binary. So this value is 8, and then this int num here that I've declared as an int type, I'm allocating a negative binary value of, and this is would be 1, that would be 3, plus 4, that will be 7, plus 8. Okay, so it should be a negative 15 there. And the last one, I'm allocating the binary value of 0 to an int value called 0, and you'll see my num1, which is that one, is minus 15, which is correct. That's a binary representation of 15. My num2, which I allocated on top here, is the positive 8, which is correct. And num3, I allocated 2. If you look over here, num3 is equal to 0b10. There's only 2 digit 2 there, but it's a value of 2. That is 0, and the first to the power 2. And then num4 is this one over here, and I've allocated all these in one line. You can see here you can allocate, and you can declare and allocate more than one statement in a line. It's just separated by those semicolons. And this one here, if you look, is minus 18, and you can work it out. It'll give you minus 18 there. And the last one is a 0, and there it is. So that is how you would allocate binary literals to an int value. Okay, the next, like I mentioned before, you can also allocate octal literals to an int value. So let's go ahead with that. And I've got a code here to show that. So we're going to use octal literal here. Now octal literals basically is to the you count from 0 to 7 the first 8, and I've got an example here. Okay, so let's look what I've got here. You got, note that 0 is a decimal literal, but 00 is an octal literal. Okay, the octal number starts with 0. So if you got 0, 1 in Java, that is not 1. That's an octal number because you started with a 0. If it was just 1, it would be a decimal literal, and then it would be 1. But 0, 1 will not be a 1. It will be 1, but in octal. Okay, so yeah, I'm showing you the scale, basically the number scale, could say, of a decimal. You can see 0 as we count whole numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a decimal till 18. Then I've got the corresponding octal. Now everything goes fine until 7 because it's the first 8. Then 8 becomes 1, 0 in octal. 9 becomes 1, 1. 10 becomes 1, 2. 11 becomes 1, 3, and so on. And 18 is 2, 2 in the octal equivalent. So yeah, I'm allocating a 0, but this is an octal 0 because it's 0, 0, and octal starts with a 0. If it just had 1 0, it would be a decimal 0, which is they're both the same value, but this is an octal 0 in Java, 0, 0. So I'm declaring octal 0 to of a type int, and I'm giving it the octal integer, but in octal format, you could say. Okay, and then yeah, I've got a num5, a variable called num5 of type int, and I'm giving it the octal value of 0 to 2. The octal value of 0 to 2 is this one, which is equivalent to 18 the way we know it. We count. Then I'm also declaring a num6 here on the same line, but I haven't allocated it a value yet. And then here I'm declaring num6 is equal to octal, a negative octal of 004, which obviously is octal 04 or 004. It could be just 1 0 there, which is a 4 here. Okay, and here I'm giving the int num7 octal value of negatives, and it starts with a 0, so we know so octal 1 0, and 1 0 in octal is 8. Okay, so if I run it, and you'll see, let's go look here, num5 is octal 22, which is a value of 18. And if I just try and move this a bit like that, you'll see octal 22 is 18. It's this one here. Okay, then num6, which is octal 004, it could also be written as octal 04, because the first one is a 0. That would be 4, negative 4. Then your num7, which is this one here, is minus, and it's a 0, so it's octal 1 0, and 1 0 is 8, and there's an 8. And obviously my octal 0, which is 0 0, its value is 0. So that is how to declare and assign octal values to a primitive int. Okay, apart from the binary and the octal, we can also express the integer literal as a hexadecimal. Now hexadecimal is to the base of 16. So let's look at an example of that. And we got it here. And you'll see I've got an example here of a hexadecimal table versus a decimal table. So hexadecimal, you'll count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the same as your decimal from there to there. But then instead of 10, it goes A, B for 11, C for 12, D for 13, E for 15. It goes until F. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10, 11, 12, 13, 14, 15, 16. So from 0 to F it gives you 16, and then it goes 1, 0, 1, 1, 2, 1, and so on until the A's and the B's and so on, 1A, 1B, 1C, and so on. Okay, now in Java you express the hexadecimal number. It starts with a 0 followed by a small or a big capital X, and yeah, I'm showing it. Okay, so let's see how we declare and instantiate or assign, actually the right word, assign a value to an int using the hexadecimal format. And yeah, I've got int with a num8, the name, and I'm assigning it 0xf, which if you look here, f is a value of 15, so that should be 15. Int num9, I'm assigning it 0x9, which should then be 9 over there. Okay, note I can put more than one statement on a line. Statements are ended with a semicolon. I'm just showing you that, yeah, instead of writing this in 2 lines like I would usually write this in 1 line, and then another line, I can write them in both lines in both in the same line in Java, because Java sees this where it stops here as one statement and that is another statement. Okay, and then I'm declaring a variable num10 of type int, and then on the next line I am then allocating it a value of negative 1a, which you'll see it is a value of negative 26 because a is 10, and the 1 in front of it, because that is a double digit, will give you this one 1 0, yeah, because it would be, that is 1a, so that could be 1 0 there. That would give you 16, so it is 10 plus 16, because a is 10 and 1 0 in octal is 16, should give me 26. We'll just have a look at that one now when we print it out, which is num10. We're printing it out there. And then my hexadecimal value, hex 0, is expressing the value of 0 as 0x0 in the hex form, which is 0 irrespective. So let's go and compile it and run it. Java main.java, and let's see the values. My num8 is 15, and that's f, and f there you can see the value is 15. There it is, there and there. Okay, now num9, which I allocated hexadecimal 9, if you go and look, hexadecimal 9 is the same value, and that gives me 9 there. And num10, which I see the value of minus 26, and it is so, there it is. And then your x is 0, obviously I use the x equivalent of 0, and it's still 0. 1, 2. A byte and a short will always fit in an int, so no casting is necessary. And what I'm showing here is I've got a byte with a variable of type byte with its max value, and I'm using again the wrapper class here, byte, and it's constant. And then I've got a variable s of type short, and I'm getting the same from its short class, its max value. And then I'm declaring two int values here, I1 and I2 of type int. And the first one, that byte b, I'm assigning the byte to an int, and yeah, I'm assigning the value of the short to an int. So I'm assigning 8-bit to a 32-bit and a 16-bit to 32-bit, and then I'm going to output the I1 and I2 values. Okay, now I'm going to run it. Okay, I'm going to say java main.java, and you can see I1 is 127, the max value of the byte, and I2 is 32767, which is the max value of a short, and I've assigned them to int values I1 and I2. Okay, just like the byte and the short, there's a range for the int. So in the first case over here, I'm just going to take this uncomment out. If I allocate one more than the minimum value, or one less than the minimum value, what will happen here? I'm declaring int I as an int, and then I'm saying I is the value over here, which is one less than the minimum value. So let's have a look at that. I'm going to save that, and I'm going to compile it and run it in memory, and you see it's giving me an error. The integer number is too large. Okay, it doesn't fit in that value, and so let me just comment it out again. And also just note, I used an underscore to separate my thousands and so on, and that is allowed in Java. You can separate when you've got a long number. You can use that separator, which we'll discuss it later on again. Okay, and possible other tutorials to follow. Okay, just showing you it there so it's easier to read. Let's see what happens in this case where I allocate integer min value -1. Remember, this is an integer because it's an operator, so the two, and I'm using int literal here, and I'm using a constant there. And let's see what happens there. I'm going to save it. I'm going to run it quickly. And that one works, and you can see, if I just do that, you can see I've allocated one less. So what's happened here? Yeah, I'm showing my min value is that one over there. It resulted in a positive value, so it underflowed, if you want to call it that. Some people call it underflow when it goes from negative to positive, and overflows when it goes positive to negative. Anyway, it overflowed, or underflowed, and then you can see my max value there. So my min value -1 overflowed to my max value, which is this one over here. Let's look. It's overflowing here. What can we do to resolve that? Over here, what I'm doing is I'm printing again the integer min value, so we can just see what the min value is. And here I'm saying integer min value -1, which would be one less than the range that the integer can have. And then I'm casting it to a long. Now, we haven't spoken about a long yet. A long is a 64-bit number, and I'm allocating L to a type of long because I'm casting it to a long. And then the actual value of int min -1, yeah, let's see what happens. I'm going to save that, and I'm going to run it. Okay, so I'm going to say java main.java, and you can see I've allocated one less than the range that the integer can have. And then I'm casting it to a long. Now, we haven't spoken about a long yet. A long is a 64-bit number, and I'm allocating L to a type of long because I'm casting it to a long. And then the actual value of int min -1, yeah, let's see what happens. I'm going to save that. and I'm going to run it, and there is my minimum value. It's this one here, integer min value. It's a minus, as you can see over there, and my value is still a positive here, so it is underflowed again. So this is still not working. That's because this result here gives me an int value, because I've got an operator give me an int value, and it's overflowed or underflowed in this case, and then I'm only casting it to a long. So it's already done its calculation and then cast to the long, so that won't work. Okay, there are two fixes that we can do. By converting, in this case, one of the int values to a long, because when you use an operator with an int and another value which is larger than an int, then the result will be the larger one. So let's look at this. Okay, so we're changing in the first example here. I'm changing the integer value, my integer dot min value. You see, I'm putting it in brackets here, and I'm casting it to a long. Now, when I've got a long here, it means, and that is a int literal there. So this integer min value becomes a long, and long minus an int the result will be a long. So let's see what would happen in that case. And the other fix I've got here is I'm leaving this one as an integer, but I'm minusing it by 1L, and that is a literal constant, a literal for a long, which we'll look at the next in the next video and so on. So let's just have a look what will happen if I compile it now. I'm just going to save it, and then I'm going to run it. And if we go and look at these last two lines here, you'll see now my min value is now a negative, and it's now one less than my actual min value. Here's my actual min value, and this one here is where it failed, where it overflowed. But my last two examples, you see that one is negative, ends with 648, and this one now is a minus, ends with 649 as well as that one. So there's two. So that's a fix. How to go from basically from a overflow into the next bigger type, which is the long. Yeah, I'm showing a mixed example. So what I've got here is num1, I'm allocating 2 to a type byte, the value 10 to a type short. Then I'm expressing my int values in the different literal formats that I can express my ints. This is a binary format, value of 11, and then a octal format. See, it's starting with 0. 0, 1, 0 in octal is a value of 8. Then this is a hexadecimal, yeah. C, which is a decimal value of 12. And then I'm adding them all from num1 to num5, and I'm putting the results. And if 2, that's 12, that's 23, 31, 43. So let's just have a look if I get the value of 43, and we have run it, and the result is 43. So yeah, I've used all the different formats and the three primitive types in one calculation that we've done until now. We've come to the end of lesson 11, data types, Java's int primitive type. We looked at the range of the int, the different integer literal formats. We also did an example on how to initialize and use a Java int data type. Hope you guys learned something from this lesson. Please send me your comments in the comment section. Please don't forget to subscribe to my channel by pressing the subscribe button. Note it's free. Press the notify button so that you will be notified when I post new content, as well as press the like button if you enjoyed the content. I've also got a Facebook page related to this channel. You're welcome to visit it. Lastly, thank you for watching my video. Please share with family and friends. Until we meet again, have a great time.